For over 40 years, one machine has been the symbol of American ground power, the M1 Abrams main battle tank. It's a rolling fortress wrapped in advanced armor, carrying a 120mm cannon that has dominated every battlefield it's seen. But the face of war is changing, and it's changing fast. For decades, the main battle tank was the king of the battlefield, but we're now in an era of cheap drones, smart loitering munitions, and advanced anti-tank missiles that can strike from anywhere. This has led to a worried question being whispered in the halls of the Pentagon. Is the tank dead? The US Army's answer isn't just a new tank, it's a completely new kind of fighting machine. A vehicle designed not just to be tougher, but a whole lot smarter. This is the M1E3, an Abrams so different from its predecessors that it marks a revolutionary shift in armored warfare. We're going to break down exactly how its new digital core and artificial intelligence are being designed to make this tank the most lethal and survivable vehicle on the planet. To get why the M1E3 is such a big deal, you have to understand the problem it's trying to solve. The Abrams has been upgraded constantly for decades. With every new version, it got deadlier, tougher, and heavier. The latest version in the field, the M1A2 SEPv3, weighs in at a colossal 78 tons with a full combat load. This incredible weight causes huge problems. It strains bridges, makes it a nightmare to transport, and drinks fuel like nothing else. In 2023, the Army made a bold decision. It announced it was pivoting away from the next planned upgrade, the M1A2 SEPv3. Army leadership admitted the tank had hit its physical limits. It couldn't get any more capable without piling on even more weight and making its massive logistical footprint even bigger. The lessons from modern conflicts were clear-cut. Just adding more armor is a losing strategy against a new generation of smart, precise, and cheap threats. A new philosophy was needed. The battlefields of the 2030s won't be won by the thickest armor, but by the smartest platform. So, the Army decided to leapfrog an entire generation of upgrades and pour all its resources into a total redesign, the M1E3. The E in M1E3 stands for engineering change, but that's a massive understatement. This is a ground-up rethink of what a main battle tank should be. The top priority is a major weight reduction, aiming for a target of around 60 tons. That's a drop of roughly 10 to 15 tons from the current model, which is huge. A lighter tank isn't just easier to move around, it's a more agile and nimble fighter, able to accelerate, reposition, and get out of trouble faster, all critical for surviving a modern fight. This new philosophy is driving a seriously accelerated timeline. The Army and General Dynamics land systems are pushing to get prototypes into soldiers' hands for feedback way sooner than normal. The goal is to have a pre-prototype out for soldier evaluation in 2025, with a small number of operational prototypes to follow. The plan is to get this tank to the front lines in the early 2030s, not decades from now. To make this happen, the M1E3 is being built around a principle called Modular Open Software Architecture, or MOSA. Think of it less like a closed-off game console and more like a high-end PC. Instead of every upgrade being a massive factory-level overhaul, MOSA creates a standardized digital backbone. This allows the Army to plug and play new software, sensors, and hardware from different developers with incredible speed. If a company develops a better targeting algorithm or a new sensor, it could be pushed to the fleet with a software update. This ensures the M1E3 can evolve at the speed of technology, not bureaucracy. At the heart of this new digital architecture is artificial intelligence. Now, let's be clear, this isn't Skynet. We are not talking about a self-aware tank making its own calls. The human crew is and always will be the one in charge. The AI in the M1E3 is being designed as a powerful co-pilot, an assistant that can process overwhelming amounts of information and present it to the crew faster and clearer than ever before. A modern battle is a flood of data, from the tank's own sensors, from drones, from satellites, and from other units. For a human crew under the stress of combat, sorting through that chaos to find the most immediate threats is a huge challenge. This is where the AI is envisioned to step in. The goal is for the M1E3's AI-assisted fire control system to constantly scan the environment with its 360-degree sensors, identifying and classifying potential targets. It could analyze the heat signature of a hidden vehicle, the electronic emissions of an enemy position, or the trajectory of an incoming missile. The system would then present this to the commander and gunner on their displays, flagging the most urgent threats. For example, it might highlight an enemy tank aiming at them as priority 1 and an anti-tank team setting up a kilometer away as priority 2. The AI assists, but the human decides. This AI-driven approach is also aimed at maintenance. The vision is for a suite of internal sensors to constantly monitor the tank's health. Instead of waiting for something to break down in the middle of a fight, the system's AI could analyze performance data to predict potential failures before they happen. It could alert the crew that a specific part is showing wear and will need replacing soon, shifting maintenance from a reactive chore to a proactive advantage, keeping more tanks ready for the fight. For decades, tank survivability was a simple math problem. More armor equals more protection. The M1E3 flips that script. Its survivability comes from an intelligent, layered defense that begins with not being seen in the first place. A key piece of this is replacing the Abrams' iconic but notoriously thirsty gas turbine engine. The M1E3 will feature a hybrid electric powertrain that pairs a diesel engine with an electric motor. This is projected to improve fuel efficiency by an estimated 40 to 50%, a game-changing reduction in the tank's logistical burden. The tactical advantages are even bigger. The hybrid system allows for a silent watch capability, where the tank can run all its advanced sensors and electronics on battery power with the diesel engine off. This, combined with efforts to reduce the tank's heat and electronic signatures, makes it much harder for an enemy to find. In an age of constant surveillance, the quietest, coolest tank has a huge advantage. The next layer is an active one. The M1E3 is being designed with a deeply integrated active protection system, or APS. Unlike older systems that were bolted onto the tank's exterior, the M1E3's APS will be built into the very fabric of the vehicle. The goal is for this system to use its radars to detect incoming threats like missiles and rocket-propelled grenades, then fire a precise countermeasure to destroy them before they ever reach the tank. This integrated system is being developed with an eye toward defending against threats from all angles, including the top-down drone attacks that have become so deadly on modern battlefields. Only after these layers of stealth and active defense does the tank's advanced modular armor come into play. By designing the tank around this layered, intelligent defense, the M1E3 can achieve a high level of survivability without the crushing weight of its predecessors. This fusion of hardware and software is redefining what a tank can be. Ultimately, a tank is judged by its ability to dominate a fight, and the M1E3 is being engineered for next-level lethality. A key part of this is the planned inclusion of an autoloader for the main gun. For its entire life, the Abrams has used a 4-person crew, with a human loader manually heaving massive 120mm rounds into the cannon. An autoloader automates this process. This would offer a consistently high rate of fire that doesn't get tired during a long fight. Most importantly, it opens the door to reducing the crew from 4 to 3. With one less person to protect, the M1E3 could be designed with a smaller, lower-profile turret, making the tank a smaller target and saving weight. While it's a major engineering challenge, the Army is seriously exploring an autoloader as a crucial step in the tank's evolution. The current plan is to retain the combat-proven 120mm main gun for now, but the M1E3's modular design is being built with the future in mind. The architecture is expected to accommodate a potential upgrade to a more powerful cannon down the road, with 130mm or even 140mm being discussed, ensuring the tank can outgun future threats. On top of that, while still in the conceptual research phase, the Army is exploring advanced munitions that could one day be fired from the tank's cannon, such as gun-launched guided missiles that could hit targets beyond the tank's line of sight. The M1E3 is being built with the digital backbone needed to control these kinds of complex smart rounds should they become a reality. Perhaps the most profound change for the M1E3 is its new role on the battlefield. It's being designed not as a lone wolf, but as the command and control quarterback of a networked team. This concept, known as manned-unmanned teaming, or MUMT, is central to the Army's vision of future combat. The M1E3's AI and advanced communications are intended to allow it to seamlessly connect with, and even direct, a family of robotic combat vehicles, RCVs, and drones. From the safety of their tank, the crew could tell an RCV to scout ahead, use a drone to see over a ridge, or order a loitering munition to strike a target they can't see themselves. Industry concepts like the perch launcher, which has been demonstrated on an Abrams, show how a tank could carry and fire its own loitering munitions, like the Switchblade. While not yet a confirmed feature for the M1E3, this would give each tank its own organic, beyond line-of-sight recon and strike capability, massively extending its awareness and lethal reach. In this vision, the M1E3 crew becomes the decision-making hub, using their AI co-pilot to manage the information flow and direct their robotic wingmen. They could send an unmanned vehicle into a dangerous area to draw fire or spot enemy positions, keeping the crewed tank out of immediate harm. This makes the whole formation deadlier and more survivable. The M1E3 becomes the central node in a web of sensors and shooters, able to dominate a huge slice of the battlefield. So, is the tank dead? The answer is a definitive no. But the tank as we knew it, a brute force brawler defined by its weight, is being replaced by something entirely new. The M1E3 Abrams represents a fundamental shift, its move away from pure mass and toward intelligent layered defense.
It swaps a gas-guzzling turbine for a stealthier, more efficient hybrid drive. It elevates the platform from a lone weapon to a software-defined, AI-assisted quarterback of a networked combat team. No single weapon is ever truly unstoppable, but the M1E3's design philosophy, built on adaptability, speed, networking, and using AI to augment the irreplaceable judgment of a human crew, is the U.S. Army's powerful bet on how to dominate the transparent, lethal battlefields of 2040 and beyond. It's not just an upgrade, it's the future of armored warfare. What feature of the M1E3 do you think will be the biggest game changer? The AI co-pilot, the silent hybrid engine, or its role as a robotic quarterback? And what new threat do you think will emerge to challenge this next generation of armor? Let us know your thoughts in the comments below. And if you enjoyed this look at the future of military tech, make sure to subscribe and hit the bell icon. You won't want to miss what we have coming next.